we get 1 times 4 equal to n times 0.082 times 273. Since we don't know the value of n, by substituting on making n the subject of the formula, we get n equals to 4.0 divided by 0.082 times 273. Note, the ideal gas equation can also be used to calculate any of the parameters of the gas. Thus, PV equals to nRT or PV over T equal to nR. For a fixed number of mole, nR is constant, therefore PV over T equals to a constant. If V1 is the volume of a given mass of gas at temperature T1 and V2 is the volume of the same mass of gas at pressure P2 and the temperature T2, then we can get the following equation: P1V1 over T1 equals to P2V2 over T2. This gives a very useful method of conversion when combined Boyle's law and Charles' law. Example 10. A gas has a volume of 500 cm cube when a pressure of 100 Newton per meter squared is exerted on it. What will be its volume if the pressure is changed to 150 mm of mercury at the same temperature? 760 mm of mercury equals to 101,323 Newton per meter squared. Solution. In all solutions, the unit for the volume must be the same. Also apply to the unit of pressure and temperature. Therefore, 1,000 Newton per cubic meter equals to 1,000 times 760 divided by 101,325, which gives us 760,000 mm of mercury divided by 101,325. Using the formula P1V1 all over T1 equal to P2V2 all over T2, we have V2 equals to P1V1 all over P2 since the temperature are the same and T equals to T2. Where P1 equals to 1,000 Newton, which is equals to 760,000 mm of mercury divided by 101,320. We have that P2 equals to 150 mm of mercury. V1 is equals to 500 cm cube. On substituting the above value, we have V2 equals to 760,000 divided by 101,325 times 500 over 150, which will give us 25 cm cube. Example 11. A certain mass of gas has a volume of 241 cm cube at 18 degrees centigrade and 753 mm mercury pressure. What will its volume be at STP? Solution. STP means standard temperature and pressure. At STP, temperature is 273 Kelvin and pressure is 760 mm of mercury or 1 atmosphere. Using ideal gas equation, P1V1 equals over T1 equals to P2V2 over T2. We get V2 equals to P1V1 T2 all over P2 T1, where P1 equals to 753 mm of mercury, P1 equals to 241 cm cube. T1 is equals to 18 plus 273 Kelvin, which will give us 291 Kelvin. P2 is equals to 760 mm of mercury. T2 is equals to 273 Kelvin. On substituting these values, we get V2 equals to 753 times 241 divided by 291 times 273 divided by 760, which will give us 224 cm cube. Dalton law of partial pressure. The law states that the total pressure of a mixture of gases which do not react is equal to the sum of the partial pressures of the constituent gases at the same temperature. The partial pressure is defined here as the pressure each gas will exert if it alone occupies the volume of the mixture at the same temperature. If we represent the pressure of gas A in the mixture by PA, the pressure of gas B by PB, the pressure of gas C by PC, the total pressure P of these three gases in their mixture will be P equals to PA plus PB plus PC. Dalton's law makes it easy for us to deal with problems in which gaseous solutions are involved. Example 12. In a sample of air collected at 0 degrees centigrade and 740 mm of mercury, the mole fraction of nitrogen, oxygen, and argon are respectively 0.78, 0.21, and 0.01. Find the partial pressure of each gas in the sample when it is collected. Solution. Mole fraction of a substance is the number of moles of the substance divided by the total number of moles in a given sample. The pressure exerted by a gas depends on the number of moles of the gas. Therefore, the pressure of gas bears a relationship to the number of moles of each gas present. Therefore, nitrogen will exert a partial pressure equal to 0.78 of the total pressure. 0.78 times 242 mm of mercury, which will give you 5.8 times 10 raised to the power minus 2 mm of mercury. By similar reasoning, partial pressure for oxygen equals to 0.21 times 742 mm of mercury, which is equal to 1.6 times 10 raised to the power 2 mm of mercury. Partial pressure for argon equals to 7 mm of mercury. Calculation involving a gas collected over water. When a gas is collected over water, it is wet because it is saturated with water vapor. If the volume of this wet gas is known and the atmospheric pressure which counterbalances the pressure of the gas in the tube is measured, the volume of the dry gas can be calculated using the law of partial pressure. Measured pressure equals to pressure of dry gas total pressure plus water vapor pressure. Pressure of the dry gas equals to measured pressure minus pressure of the water vapor, or pressure of atmosphere equals to pressure of dry gas plus pressure of water vapor.